Hello again, everybody. We're going to be doing some more nerd deep dive stuff today. If you didn't get to catch the last video we did, which was breaking down the Dallas Rangemaster, I am just going through some classic circuits that I feel like I know well enough by memory, and then I draw them out, and then I go back and I check them after to make sure I'm not giving you guys misinformation. And then I think about what I actually know about what that circuit is doing. I thought that might be a fun thing to share with you guys. Last time we did a one knob pedal with one transistor. So this time we're going to be doing a two knob pedal with two transistors. And what is this? This is the fuzz face, more specifically a germanium fuzz face. The most coveted of fuzz face. I actually prefer silicon ones, to be honest, but let's just jump right into it. Let's talk about what components are in this thing. There's very few of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, if you include the potentiometers, rather the knobs, the controls. That's not a lot, right? Pretty simple circuit. Starting at the input, this is where you plug your guitar into, right? We have C1, which is 2.2 UF. That's actually a fairly large capacitor, especially in comparison to what we had on the Dallas Rangemaster, right? That was 5 NF, way, way, way smaller. NF is 3 times smaller than UF, all 3 decimal points over. Don't say 3 times. Don't do that. Make the math harder for yourself. But this value allows basically all of your guitar signal to pass through. Anything it would be rolling off at lower frequencies or, subsonic. You wouldn't be able to hear them at that point, for the most part, at least. That also blocks some DC at the input. That has to do with DC going back towards your guitar, so it kind of prevents that from happening also. But it is our first component before we hit our first gain stage, right? We have Q1 here, which is an AC128, which is a PNP transistor. If you saw the last video, you know that means that it has what we call positive ground. Now, normally we think about ground as negative in electronics, and generally speaking, like the negative side of a battery terminal, like a 9-volt battery. But in this case, we have positive ground, right? And that means that we have negative voltage. So we're taking in negative 9 volts is the way that it works, assuming you were operating with a battery, because these all operated on a battery. There wasn't really another option back then. So going into it, our emitter right here to help bias this transistor is connected directly to ground. And then R1 at the collector has some resistance between that and our supply voltage, right? So it's 33K. What does this really do? This is a bias point that it allows for a max collector current. Okay, so what that means is you can only put so much voltage into here. Okay, this kind of like stops it from giving it the full voltage supply. Whether that be to make it operate appropriately, whether that be to or operate inappropriately, or just to protect the transistor itself, right? So after that, we have another gain stage, right? So it's another AC128, okay? These could be swapped, flipped, whatever. Generally speaking, I feel like people usually want the lower gain one here and the higher gain one here. And like I said, they are the same, but all transistors are different, right? They have there's a number that we like to look for in transistors called the HFE, and that kind of directly correlates to how much gain it can output. Generally a higher number means crunchier, and more fizzy, whatever you want to call it. But you notice this emitter isn't connected to ground, right? What do we have going on here? So we have R4, 100K. It's actually feeding back into the base of Q1, our first transistor. Now, why would we do this? This creates what we call feedback. This is a feedback network. Feedback is how we make a gain. Now, you guys probably think about feedback holding a microphone directly into a speaker and making a horrible sound. It's not far off from that, to be honest. It's just a little more controlled. It's a little too nuanced for me to jump into in this video, but hey, you want to talk about negative feedback? I'll talk about negative feedback all day. You guys can give me all the negative feedback you want in the comments for not talking about negative feedback. Do enough of it and maybe I will talk about it. But until then, let's talk about the fuzz face and how it is biased at the emitter. So we have our first control here, which is our fuzz, our attack control, whatever you want to call it on a vintage fuzz. And it is essentially working like 2 variable resistors at the same time, right? So not quite like a voltage divider, but essentially, the more you turn to the left, the more resistance there's going to be between pins 2 and 3. And the more you turn to the right, the more resistance there's going to be between pins 1 and 2. And you can always find pin 1 by this little tiny dot right here next to it, or at least hope you can. There's plenty of schematics out there that don't have them, and they are terrible because you never figure out essentially what's going to happen. You're going to put the pot in, and if it's not the right way, down's going to be up and up's going to be down. It's very frustrating when it happens, especially when you design a PCB for it. You can't just flip the wires. But anyways, I digress. That is a pedal builder problem. In parallel, with pins 1 and 2, we also have this capacitor, and it's just similar to the same thing we talked about on the Rangemaster, where it kind of enables for you to have gain regardless of the bias point. So no matter what this value is, you know, between these two pins, it still enables us to make some crunchy goodness, right? So also, you notice this one is flipped, right? Because again, we're operating as if this is positive ground. So the positive side is going to be over here. If we were working with a silicon transistor that was NPN, that's the opposite of PNP, go figure, we would have to flip this guy, right? And there's a lot of other changes we'd have to make with different materials of transistors, different values of transistors. It could be a different germanium transistor. We'd probably have to change some values, right? But this is one for an AC 128. So next up, like we kind of control the voltage here for this transistor, we have to do the same thing here, right? So we have two resistors in series, okay? And the way series resistors work is the easiest math you will ever do in making guitar pedals. You just add the values together. Series means you take, you know, this one's 470 ohms. R3 is 8.2 thousand ohms. If you add those together, what you get 8,670 ohms, right? Okay, for whoever's counting. That resistance between our supply voltage and the collector of this transistor brings us somewhere in the neighborhood of half the supply voltage. Okay, now we are operating at -9 volts because again we have positive ground, so -9. It gets us to about -4.5 volts, half the supply voltage, right? -4.5 plus -4.5 is -9 volts. Why do we do that? It gives you a really nice even swing between both sides of the sound waves. So what we really want with a fuzz face is what sounds best to your ears, but most people will tell you that -4.5 is like the Mojo. That's like the place to put it at a fuzz face. It's electronically, mathematically the correct way to do it. I actually like to overbias them a little bit, but we'll talk more about that later when I go over some mods and stuff we can do to these things. So sorry I'm playing with my hair so much. It's only one color and it's driving me nuts. The other thing these two resistors do is they create a voltage divider, which is something we talked about before. So if you have two resistors connected at opposite points and then you connect them in the middle, whatever happens in the middle is going to be like half of that supply voltage. That's like the easier way to explain it, you know, similar to actually how a guitar volume pot works, which we will go over in this video. But this doesn't do much. This value is too small and this value is too big. You know, the closer they are together, the closer you get to like the halfway point. So like if, you know, this was 8.2 and this was 8.2, this right here would, you know, be whatever half the voltage is, right? That's kind of the way that it works. So this capacitor right here is the same thing as this one over here. Okay, so it's like it cleans the DC at the output of the circuit instead of the input. But it has a secondary purpose also. It also functions as a high pass filter depending on where you turn this knob. Now this is just the volume knob. Hopefully you guys know what the volume knob does on the guitar pedal, but it controls how much output you have. And the output right here is like what would go into your amp or the next pedal or whatever in the chain, right? So the way this works is just like I said, just like a guitar volume pot, where as you roll it towards pin 1 to the left, it runs your output to ground. Okay, but as you turn to the right, it runs the output towards all this fun stuff we just did over here, right? And the closer we are to that, the more of the fuzz we get, obviously. So like I said before, these are variable resistors essentially. So this information changes, okay? Which means the relationship from this side to ground over here also kind of changes, right? And what that means is just like we had, you know, filtering where you would go a capacitor and then a resistor directly to ground and then continue your signal path, you have to take that into account here. And this goes into what I was saying before, right? It's like nothing's really linear when it comes to a guitar pedal. Everything kind of does more than one thing most of the time. I don't want to say everything. What this means is that this cuts out low frequencies the farther you turn it to the left. That means as your guitar gets quieter, your pedal gets quieter, you also lose bass frequencies, which means there's something to be said about loud being better, right? So the best way, in my opinion, to run a fuzz face is everything dimed. I actually think that's pretty much the only way it sounds good, if I'm being totally honest. That's because you are now slamming the amp with more bass frequencies. Like if you were to turn the amp up but the pedal down, it's not gonna sound the same as if you turned the pedal up and the amp down, right? For a lot of reasons, this being a very important one. I always like to add a couple of mods into the end of these if you guys are at all interested. This cap is the easiest mod. You switch this out to a bigger value, you'll get more bass from your guitar coming into the signal. Switch it to a smaller value, less bass. It's pretty much simple enough, right? This one actually is kind of already in here. This normally requires a linear potentiometer, which means the taper just goes directly from, like, you know, if it's at the halfway point, it's at 50% of the value of the potentiometer, which in this case is 1,000 ohms, 1K. I actually think it works better with an anti-log taper. It's still 1K, but some of the information that's bunched up at the sides of the knob are kind of pulled towards the middle. And I think that's how the gain knob sounds best for a fuzz face. Actually, that's not true. The way I think a gain knob sounds the best for a fuzz face is all the way up. That's the only option. I would rather have like a bias control, like putting a little trim pot right here to kind of control that, you know, whether or not this is actually the negative 4.5 like we talked about, or if it's, you know, if you put too much voltage into it, it's going to get splatty and velcro-y. If you don't put enough, it's going to be like a more anemic and kind of like a dying battery sound, right? That's a more useful control to me than this will ever be. And you'll see a lot of boutique guys, if they don't have it on the outside, they usually have it on the inside and a little trim pot to kind of get their perfect bias point. But that is the fuzz face. There's not a ton of things you can really do to mod it. I mean, you can go, you know, replace every resistor with a potentiometer. There's guys that have certainly done that before. But overall, it's this kind of a if it ain't broke, don't fix it kind of thing. But to taste, you know, you can make it your own. I personally, like I said, don't really love the germanium ones. I like the silicone ones better. But to each their own. Thanks so much for watching the video. If I made any mistakes, please let me know. If anything was confusing, again, write it in the comments. I love talking about this stuff. This is just a mental exercise for me at this point. But yeah, again, let me know what circuits you guys want me to cover. I got a couple in mind already that are just classic ones that are easy to do. Please like and subscribe. And I will see you next time.